Hello everyone, welcome to today's webinar. Today we will go over the most important topics on Unit 1 Geometry. This is myself. My name is Miriam. I'm the math instructor here, and I did join the team here at Penn in October 2015. I am certified to teach high school math since 2010, and I had earned my master's last year. Today in this webinar, we're going to go over some objectives of the unit. That's not everything that we need to know for the unit or the exam, but these are the most important topics that I felt that students have questions always on those topics. So we're going to go over complementary, supplementary angles. We're going to go over the system of parallel lines cut through by a transversal. We're going to look at how to calculate the angle measures using degrees, minutes, and seconds. Time to angle measure, we're going to know and learn how to relate that. And also we will look at how planes, when they intersect solids, what happens and what is the result of the intersection. Let's begin our webinar with adjacent angles. You know by now, if you have read the unit, that we classify angles depending on its individual measure. So we have acute angles, we have obtuse angles, and so on. There is another way to classify angles. So the other way is to add the measure of the two angles, whether they are adjacent like you see on the screen or non-adjacent. If you add the measure of the two angles and they happen to be exactly 90 degrees, we call the two angles complementary pair. So for example, on the angle that you see on the top here, angle CBA, you will see that the given in the question have a box on the corner of this angle. This is given in the question. That means that this angle is a right angle. So this big angle CBA is a right angle, meaning that it measures 90 degrees. If you look at the two smaller angles, CBD and DBA, you will notice that the sum of these two angles will end up 90 degrees. That means that these two angles are complementary. If the question gives you the angle CBA and tells you that this angle is right angle and one of the smaller angles measures 55 degrees, are you able to find the measure of the second angle? We can do that by simply subtracting. So 90 degrees minus the known one, which is 55, will give you the measure of this angle. So it's a simple subtraction, and that will then give you the measure of this angle, which is going to be 35 degrees. The same way, this angle is given as a right angle divided into two different angles. That means that the sum of the measure of this angle and this angle should be 90 degrees. I am able to call these two angles complementary angles, and also I'm able to calculate the measure of this angle NPS by subtracting 90, because altogether it's 90 minus part of it is 23. So that will give us the measure of the other angle, 67 degrees. So that is how complementary angles work. Sometimes when you read the lesson, the wording itself may make the concept harder than it is, but it's really simple. Add the two angles. If they are 90 degrees, then they are complementary. If they are complementary and you're given one of those angles, you're able to do subtraction and find the other measure of the angle. Another way to classify the angles is if the straight angle like IMO is divided into different two angles. So PMO and PMI, they are adjacent angles. And the sum of these two angles is 180 degrees. How did I know it's 180 degrees? Because the angle IMO, as you see from the figure, it's a straight line, meaning that it's a straight angle, and a straight angle always measures 180 degrees. So if two angles, they are adjacent, when you add them up, when you add the measures up, it will end up with 180 degrees. We call them supplementary angles. And the same way with like we did with the complementary angles, we are able to use simple subtraction to find the unknown angle. In this example, for example, you have IMO, a straight angle. You have part of it 25 degrees, then the other angle would be simply 180 minus 25 degrees, and that will give you the measure of PMO, which is going to be 155 degrees. Second example, the same way, ABC from the figure, even if the wording of the question does not tell you exactly that ABC is a straight angle or measures 180 degrees from the figure, you are able to determine that ABC is a straight line, and therefore ABC is a straight angle measures 180 degrees. If you know one angle, then the other one can be found by subtraction. 180 minus 78, and that will give you the other angle, 102 degrees. I need to remind you that you are able to ask your questions using the questions box. If you have any question relevant to the lesson or to this unit, you are able to type in your questions, and I'm going to check the questions frequently throughout the webinar. I'm going to try my best to answer the relevant one. Okay, next we have another kind of adjacent angles. If you look at these two examples, the angle ROP and TLM, both of them are neither right angles, and they are not straight angles. So in this case, we are not able to say the ROQ or Q and QOP, they are not complementary and they are not supplementary. Some students, they think that when two angles are adjacent, they have to be either complementary or supplementary. That is not true. They are only complementary if the sum is 90 degrees, and it's going to be supplementary if the sum is 180 degrees. Otherwise, it's going to be neither of the two. So in this case, for example, ROP in the question given as 77 degrees. So the measure of the total angle here, 77 degrees, and you know part of it 45 degrees. We're going to still use subtraction, but we're not going to use 90 or 180. We're going to use the 77 minus the part of the angle 45, and that will give you the other angle. So if you use simple subtraction, you're going to do 77 minus 45, and that will give you 32 degrees for this angle. So this angle, 32 degrees. The same way, if the angles are two adjacent angles, then it does not have to be complementary or supplementary. In this question, for example, the angle TLM, which is the angle here, measures 100 degrees. Part of it is 10 degrees. Then I'm going to do subtraction 100 minus 10, and that will give you 90 degrees. One thing I need to mention with geometry, any geometry course that you're going to take, either it's a high school level or college level, do not try to measure the angles given you in a figure. Usually the angles or the figures that are given in a question, they are not drawn to scale. So even if you try to measure those angles and try to solve the problem, that will not gonna get you to the right answer. You need to use the givens in the questions. You need to use the theorems and facts that we learn in geometry to conclude things given in that figure or question. So measuring angles or the length of sides on questions will not going to be the best way to go about the question, because again, we do not usually, the questions and the figures on any geometry exam is not drawn to scale. What about non-adjacent angles? So adjacent angles, they share a vertex and a side or a ray. In these two figures, you will see that the two angles are separate. So they are not attached. So they are not adjacent, but that does not mean that it will never be supplementary or complementary. Again, supplementary or complementary depends on the sum of the two angles. So if we happen to see in the wording of the question anything saying that the two angles are supplementary or complementary, that would be enough for us to use as a fact and base our calculations on that. So for example, the first figure here, the angle pair ABC, and DEF is supplementary. So it's given the fact that these two angles are supplementary. What is the measure of angle DEF? DEF. So the fact that they are supplementary, I'm able to use the simple subtraction 180 because it's supplementary minus the given angle, and that should give us the measure of the DEF angle. So 180 minus 105, and that will give you 75 degrees. So that is 75 degrees. The second question, the angle pair QLM, so that the smaller one, and TRS is what? Complementary or supplementary or none? To know that, add the sum of the two angles. So 60 and 30 is what? 90 degrees. So that means that this pair is complementary. I'm just reminding you, if you have any questions, feel free to type in the question. Just keep them relevant to the webinar. Okay, this is a self-check question. These questions are not graded throughout the webinar. These are given to you to practice what we have gone through so far in the webinar. So we're going to read the question together, understand what the question is asking, and then I'm going to change my screen so it gives you the same question without the figure though, and you'll be able to choose the right answer from A, B, C, or D. The question is asking, examine the figure below, then answer the following questions. The angle pair ABC, so whenever the question is giving me an angle and names it, I need to identify this angle on my figure. So I'm able to relate the angles together. So the angle pair ABC, so they are talking about this angle, and CBD, so this angle. Is this pair supplementary, complementary, straight, or right? What do you think? Okay, now I'm going to change my screen. You'll be able to choose the answer. And remember, if you have the answer incorrect at the end, do not get discouraged. The reason for this webinar is that you know how to study for the unit, is to know the key points on this unit that you definitely have to master before you go ahead and take the exam. So even if you got it incorrect, it does not mean that you're going to fail the exam. It just means that you need to go over that topic again on your unit or reach out for help before you attempt the exam. So the question is here, and you're able to choose your answers. Okay, I'm waiting for everyone to have a chance to answer. Remember, you need to relate both angles. We're not asking about the measure of each angle. So the measure of each angle is not what we're asking in the question. We're asking about the pair. The relationship between the two angles in that pair is what? One of the answers given there is kind of right, but the best answer is only one of the given choices. Okay, let's do the question together. So since the sum of the angles, the measures of these two angles is 90 degrees, and I know that because on the figure they gave me a symbol to give me the idea that the bigger angle ABD is a right angle, and because there are two adjacent angles within this bigger angle, I know that the sum, without knowing any angle measures, I know from the figure that these two angles are complementary to each other. Right angle, the answer D is not the perfect answer because not each angle measures 90, and right angles is not a relationship between two angles in a pair, so complementary is the right answer. Okay, let's see the next question, the same figure, and this time it's asking us to find another answer. The angle pair FBE. So FBE. So this angle and EBD. EBD is what? Supplementary, neither supplementary or complementary, adjacent, or straight. What do you think? Before I change my screen, look at the figure. These two angles are what? The best answer from the four given is what? And here's the question. Remember that the relationship does not have to be always supplementary or complementary. Any fact that is true on that pair that we have on the figure would be the best answer from the four given. So think about which one is the right one regarding the two angles that we pointed at together. Okay, let's do the question together then. If we look at the figure, we would notice that FBD and DBA are two adjacent angles, and they make together a straight line. And since one of them, which is this angle, is 90 degrees, that would make me do 180 minus 90, and that will give me that this bigger angle is also a right angle, 90 degrees. So now I know that the pair FBE and EBD is complementary. None of the answers says complementary. It says supplementary. That is not correct. The sum is not 180 degrees for these two. Neither supplementary or complementary. That is not correct because this pair is complementary. Adjacent or straight. Well, the straight means that both measures added together will give you 180 degrees. That's not correct. Adjacent. Yes, these two angles are adjacent. They share a vertex and a ray. So the best answer that describes the pair is adjacent. Let's do the next question, and it's going to be on the same figure. The measure of angle FBE. FBE. So they're trying to make us calculate the measure of this angle. Well, we know in the previous question that these two angles are or is a complementary pair. So that give us an idea on how to find the measure of this angle. I'm going to put up the question and you're able to select your answer. What is the measure of this angle? And here you go. Okay, let's do the question together. So since we know that this pair, FBE and EBD, is complementary, we know that we have to subtract 90 degrees minus 20 degrees, and that will give you the measure of this remaining angle, which is going to be 70 degrees. And that is the answer. Next question on the same figure. So far, we know that this angle is 70 from the last question. And this time it's asking us if the measure of angle ABC, so ABC, this one is 58 degrees. Then what is the measure of EBC? It's looking for the angle measure for this angle. How can we find the measure of this angle? Look at the figure and try to find relationships between the given angles so you're able to find the measure of EBC. Okay, I'm going to put up the question. Here you go. Okay, remember that we're not looking for the angle measure of DBC, this one. We're looking for the whole thing. So if you're able to find this measure, what would you need to do to find the measure of this angle rather? Okay, let's do the question together. So in this figure, I'm going to change the color to make the concept clear. If I'm looking at this pair here, the one in blue here, this angle is a right angle. That means that this angle and this angle are complementary, meaning that I'm able to find the measure of this angle CBD from doing 90 minus 58 equals to, and that will give you 32 degrees. So this angle alone, this one here only, 32 degrees. The question is not asking me to get the CBD measure. They want us to get the whole angle EBC. So since I know this part and this one I did find, add 20 plus 32, and that will give you the angle measure EBC to be 52 degrees. Any questions? Anything that was not clear on this one question? This one question is a typical exam question because it makes you do lots of steps to find the final answer. So when you do the exam, any exam, I'm not referring to a specific exam, do not expect the questions to be straightforward. They may ask you to use different concepts together to find the final answer. Okay, next. The next concept that you want to go over in this webinar is the system of two parallel lines when they are cut through by a transversal. Where is a transversal in this case? And that would be this line. This line is DH, or if you want to name it, HFBD. This line is what we call the transversal. And these two lines has to be parallel in order for the next relationships that we're going to go over to be true. So these two lines needs to be parallel. In the wording of the question, if they give you that structure, they have to mention that line 1 and line 2 are parallel in order to find vertical angles or to alternate interior angles, alternate exterior angles, and corresponding angles. So this topic, I think, is the most challenging one because you will have to find different pairs on the system depending on what you are asked to find. So let's then define the different 4 types of angle pairs in that system. So the first one I'm going to go over is the vertical angle. I'm going to keep the color coding here so we are able to clearly see the pairs that we're going to identify. So the two lines are parallel and there is a transversal cutting through these two lines, then we are able to say that vertical angles are congruent or having the same measure. So where are the vertical angle pairs on that system? So vertical angles like this angle, for example, and this angle. We call them vertical because they share a vertex. This point is the head of the two angles. It's the same for both. So that's why we call them vertical angles. Another pair of vertical angles would be like this one and this one. And as I said, they are congruent. They have the same measure. So for example, if you have this angle as 20, then the vertical angle would be 20. And so on. So how many pairs we are able to find in this system to be vertical pairs? There are 4 pairs of vertical angles. The next type of angle is alternate interior angles. We need to understand why we name those pairs like this in order to locate them correctly on the system. So alternate meaning that each angle in that pair is located on a different side of the transversal. One would be to the right of the transversal here, and one angle would be to the left, and that's why we call them alternate, the alternate positions. Interior, meaning that they are to the interior of the system, so it will be in between the two lines, so that is the interior. So having said that, we are able to say, well, this angle here and this angle both are alternate interior angles. So again, one to the right of the transversal, the other is to the left of the transversal. That's why the alternate part of the name. Interior, they are to the interior part of the system. And in this case, we say the alternate interior angles have the same measure. They have the same measure. So, for example, since this one is 20, so this one, because they are supplementary angles, that would be 160. And because this angle and this angle are alternate interior angles, they have the same measure, then this one would be 160 as well. How many pairs we have as alternate interior angles in this system? We have 2 pairs. 2 pairs. Next one is alternate exterior angles. So we know the alternate part is that each angle is on a different side of the transversal. Exterior, though, would be the exterior of the system. So that is an exterior, and that is an exterior. So one angle would be, for example, here, that is to the outside and to the left of the transversal. So the other one would be to the right of the transversal and still outside. So that would be the other angle in that pair. And again, alternate exterior angles have the same measure. So this is 160. So this one, because it's an alternate exterior angle to this one here, so that would be 160. The last type of angles, and before I leave that, it's 2 pairs as well. The last one I want to go over is corresponding angles. So corresponding angles, they have corresponding positions on both lines. So this angle, for example, here, this angle in purple, and this angle, they are corresponding angles. Both of them to the top of one line and to the left of the transversal. Here, the same thing, to the top of one line and to the left of the transversal. They have corresponding positions on the system. So that's why we call them corresponding angles. And they have the same measure. They are congruent. So since this one, we said it's 20 degrees, then this one also would be 20 degrees. In your notes, if you want to draw that system and keep it in your notes as a reference, just to have something to go back to whenever you're working on any question about this system, you are able to keep that. And then by practice, you will be able to easily identify pairs of angles on that system without going back to that reference. Any questions? Anything that was not clear or did not make sense in this slide? You are able to type in your questions in the questions box. Okay, let's go to a self-check question, again, that is not graded. Let's read the question together. If lines L1 and L2 are parallel, what are the measures of the following angles? Choose the right reason for your answer. So in each of those questions, this one and I think the next 4 or 3, you will be able to identify the measure of the angle and why do you think that this is the measure of the angle, the reason. So the first question here, the measure of NCB. So whenever an angle is given to me in the question wording, I want to go ahead and point at it on the figure given. So I would, in my mind, relate the other angles to that angle. So NCB. So this one is the one that we're asking for the measure for. The only given in the question is the 2 lines are parallel. And also they gave us the angle measure ADM to be 30 degrees. What should I do? What should I use from those facts? Is it 30 degrees because alternate interior angle with MDC? With MDC. So are these 2 angles are alternate exterior angles? 30 degrees because alternate exterior angles with ADM? ADM. And this angle, are they alternate exterior angles? The first one was interior, this one is exterior. Which one is the reason? Or maybe it's 150 degrees because supplementary with BCO. BCO. Or maybe it's 150 degrees because it's corresponding to D I'm going to leave that figure a few seconds so you're able to decide on the answer, and then you can just go ahead and choose your answer whenever I change the screen. Okay, let's go to the question on the other screen and see which one is the right measure. Here you go. Okay, let's do the question together. So the measure of NCB, this one is what? Well, I see that this angle NCB with ADM together, they make an alternate, one to the right, one to the left, exterior. This is to the outside, and that is to the outside angles. And that's why they will have the same measure. Since one is 30, the other one will be 30 as well. So those answers are eliminated. And we said that both are to the interior of to the exterior of the system. Both of them are to the outside of the system. Then the answer is B. It is 30 degrees because it's alternate exterior angle with ADM. Next question, the same figure. So far we know that this is 30 and this is 30. The question now is asking, what is the measure of the angle NCD? NCD is this angle. So which relationships I'm able to use given that the lines are parallel, there's a transversal, and there are two angles I know the measure for? Is it 30 degrees alternate interior with ADP? So is this angle alternate interior with ADP? Is it 30 degrees corresponding to MDC? So we're talking about this angle, and the other one they're mentioning in the answer, MDC. Is it corresponding angles, these two? 150 degrees because supplementary with NCB, so this angle, NCB, these two are supplementary, or 150 degrees because it's corresponding with ADM. So are these two corresponding angles? I'm going to leave the figure, choose your answer in your head, and then you'll be able to submit your answers. Okay, and here you go with the question. Remember that corresponding angles, they have the same exact position on each of the lines. So if you do not think that the answer given tells the right relationship between the angle and the other one, then that was not the right answer. But if you think it is, then it is corresponding. Okay, let's do the question together. I hope everyone had a chance to answer the question. These are practice questions. Again, not graded. I'm not going to track who did right or wrong, but these are practice on the concept that we go over. Okay, let's do that together. So this angle then is alternate interior with ADP. ADP, these two are alternate interior angles. That's not correct. One is to the exterior and one is in the interior. That is not correct. 30 degrees and corresponding to MDC. MDC is here and this angle is there. They are not corresponding. These two angles are what? Alternate interior angles. So that is not the right answer. 150 and supplementary with NCB. Well, NCB is 30. The line itself is 180 degrees because it's a straight angle. One missing angle, then simple subtraction, 180 minus 30, and that will give you 150. So the right measure is 150, and this is the right reason. It is supplementary with NCB. So C is the right answer. Although this answer here, D, have the right measure, the reason is not correct. This angle is not corresponding to ADM. This angle and this angle are not corresponding. Next question on the same system. So far, the measures in blue on that figure are the ones that we already know from our previous questions. Now, this question is asking what is the measure of the angle MDC? So MDC would be this one. This is the one that we're trying to find the measure for. Is it 150 degrees because it's alternate interior with NCD? NCD. Are these alternate interior angles? And does that measure 150 or no? Is it 30 degrees corresponding to NCD? NCD. So are these two angles are rather corresponding or alternate interior angles? What do you think? C, supplementary with PDA. PDA. Are these two supplementary? And the last one is this angle corresponding to NCD. NCD. I'm going to leave the figure for, I think, a little bit more longer time because I think you need more time to relate the angles. We're still learning the concept. So I'm going to leave it longer. Choose the right answer with the right measure. Okay, let's then put up the question. What is the measure of MDC? Remember, you have to choose the right measure and the right reason for the measure. Twenty more seconds, and I'm gonna do the question together. Okay, let's do that together. So this angle measure is 150 degrees, and the right reason is that NCD is alternate interior angles with this angle, 150 degrees. So the answer is A. There is another answer, but it's not given in the answer choices. You can say, well, ADM and MDC are supplementary, and that's why it is 150 degrees. So there can be multiple reasons for your right answer, but you need to choose the one right reason from the given answers. Okay, the last question on that figure, the measure of DCO. DCO is what? Is it 150 degrees? If you look at the figure here, leave the reason aside, but what is the measure of this angle? Since these two angles are supplementary angles, one of them is 150 degrees, the other one would be what? That will make you eliminate some of the answers here. So is it 150 degrees or 30 degrees to begin with? And from that, you are able to eliminate the wrong reasons as well. I'm going to leave it longer since you need then in this question to go over each answer and relate that on the figure like we did in the other 4 questions together, but this time you're gonna do it yourself, so you're training for the exam to inspect each of the answers and eliminate the ones that definitely are incorrect. If you have any questions, the raise your hand feature is not enabled in the webinar. If you have a question, you can write the question in the questions box, and I'll be happy to answer that if it's relevant to the webinar. So again, what is the measure of DCO? I'm going to put up the question. DCO is what? Is it 150 or 30 degrees to begin with? And what is the reason for your answer? Twenty more seconds, and then we can look at the question together. Okay, let's do the question together. The only right answer is B. And if we look at these two angles here, NCD and DCO, they are supplementary angles. One of them is 50, the other one should be 30. So I'm going to eliminate anything that says 150. All I need to do then is to determine the reason. Is it vertical with NCB? Is this angle vertical with NCB? Yes. What about the other option? Is it alternate exterior with MDC? Well, the angle itself is interior, so that is right away no. So the only right answer is B, vertical with NCB, and it measures 30 degrees. The next topic, we're going to go over time, over the hour. So if you want to stay and watch the whole webinar, you're able to. If not, you're still going to receive a recorded webinar about a couple of hours after the conclusion of the session. Find the complement of an angle that measures. This time, the measure is not given in only degrees, but it is given in degrees, minutes, and seconds. In your unit, you are asked to do calculations with fractions of a degree. So since the question is saying that the angles, the two angles, one of them measures this, the other angle would be how much? Well, complement is a key word, meaning that this angle measure plus the other unknown angle measure should give you 90 degrees altogether. So the same way we used to subtract 90 degrees minus, for example, 55 if the measure was given only in degrees and do the subtraction. But since the measure now is given in degrees, minutes, and seconds, then we need to consider those fractions also in our calculation. So we're still going to do 90 degrees, 0 minutes, and 0 seconds minus the part of the angle 55 degrees, 12 minutes and 36 seconds, and do the subtraction. That looks like the subtraction that we used to do in elementary school when we had to borrow, because 0 minus 36, we need to borrow from the next column over to the left. And that is 0. It does not have anything to give us. So we have to go for the last column to the left, which is the 90 degrees. We're going to borrow 1 degree from 90. So if we're going to borrow 1 degree from 90, the 90 will no longer be a 90. It will be 90 minus 1. So that would be 89 degrees. And it will give 1 degree to the minutes column. There are 60 minutes in 1 degree. So 1 degree will be given to this column, which is equivalent to 60 minutes. Now remember, in subtractions like vertically like this, we cannot do the subtraction in the middle column yet. We have to start from the far right column. So again, the minutes column have to give 1 minute to the seconds column. So that will give 1 minute to the seconds column. And there are 60 seconds in 1 minute. So that would give 60 seconds. Now we are able to perform the subtraction. 60 minus 36 will give you 24 seconds. 60 minus 12, and this, by the way, we need to do the borrowing here, so that is 59 minutes because it gave 1 minute to the seconds column, so that is no longer 60, so that is 59 now. So 59 minutes minus the 12 minutes, that would give you 47 minutes, and then 89 degrees minus 55 degrees will give you 34 degrees. So the other angle that is complement to this angle is 34 degrees, 47 minutes, and 24 seconds. Any questions on this topic? You can type in your questions in the questions box if you have any. So next, let's do the same thing. Find the supplement of 130 degrees, 25 minutes, and 40 seconds. Are we going to use 90 minus or 180 minus? What's the key word in this question? You are able to set up the subtraction vertically, borrow as needed, and do the subtraction. So I'm going to leave the screen here for a few seconds, write down the problem, and then I'm going to change the screen for you to choose the right supplement of this angle. Okay. What is the supplement of the given angle? Remember that we have to borrow twice. We have to borrow once from the degrees column, and then we have to borrow again from the minutes column. Twenty more seconds, and we are able to go ahead and do the question together. Okay, let's do the subtraction together. So since the key word in this question says supplement, we're not going to use 90 like the other question. We have to use the 180 degrees. Since we're dealing with minutes and seconds, then we have to specify 0 minutes and 0 seconds minus the given angle, 130 degrees, 25 minutes, and 40 seconds. 0 minus 40 cannot do. Then borrow from the next column, cannot borrow anything. So go to the last column to the left, the degrees, and borrow 1 degree and give it to the minute column. So that would not be 180 anymore. It's going to be 179 degrees. Give 1 degree, which is equivalent to 60 minutes. We cannot do the middle column with the subtraction yet, so we have to borrow and give the seconds column. So that is not 60 anymore, that is 59 minutes. And the minute column would give 1 minute to the degrees column, which is going to be 60 seconds. 60 minus 40, of course, is 20 seconds. 59 minus 20, 5. So 59 minus 25 will give you 34 minutes. And then 179 minus 130 will give you 49 degrees. And keep the units there, because that what tells you which part or fraction of a degree it is. So the answer, the supplement of this angle is this angle. And the answer is B. Any questions? Anything that was not clear on the calculations that we did with the subtraction? Okay, next topic. We are going to relate time with angle measure. So a question that is found in your lessons that ask you something like that. What is the angle measure between the clock hands when it is 5 o'clock? So basically what the question is asking you is to find the angle measure here. Let's call it C, angle C. So this is the measure of the angle we're looking for if it is 5 o'clock. And that is using the traditional clock with the hands. So to do that, we need to remember some factual informations about time and circles. So one full round around the clock would be 12 hours. So one round equals to 12 hours as far as time. And one full round around the circle is 360 degrees. So one round also in terms of degrees is 360 degrees. These are the reference information or factual information that we're going to use to set up our proportion. Proportion is two equal fractions. On the bottom, we're going to have our factual information, 360 degrees, one full round, is equivalent to 12 hours in terms of time. Now, what we need to do is to write the top parts of each fraction on the right position. So since this fraction deals with degrees, it's going to have on the top the measure of angle C, which is unknown. We still need to calculate that. But we know the time relevant to the measure C, which is 5, because so far the time has gone through 5 hours out of the whole circle, out of the whole clock. So 5 hours. So this is a proportion. To solve the proportion for this value, M, the measure of angle C, I do it this way. Cross multiply and then divide. So the measure of angle C equals to cross multiply 360 times 5 and then divide over the remaining known value, which is 12. So in your calculator, you're going to punch in 5 times 360 or 360 times 5 equals 2, and then divide over 12 equals 2. And that will give you 150 degrees. So when it's 5 o'clock, the angle between the hands is 150 degrees. 150 degrees. That's it. So all you need to do or know for that topic is to how to set up the proportion. The first fraction will always have the degrees. The second fractions will have the time, either in hours or minutes. In this time, because the question says 5 o'clock, we know it's talking about hours. If it gives us time in minutes, then we have to use the minutes. Questions on this topic? Anything that did not make sense? Okay, let's do a practice question on the same topic. What is the angle measure between the clock hands when it is 2 o'clock? If this figure is not drawn for you on the question, you want to draw a figure for yourself and do the minute hands at 12 and 2 just to visualize what the angle would look like. Of course, you're not going to measure the actual angles with tools, but you will just have a sense of what the question is asking you to do. So set up the proportion. You have two fractions. What goes on the bottoms and what goes on the top? Okay, and here's the question. How many minutes, how many hours in one full round in terms of time? And how many degrees is a full round around the circle? you're always going to have the reference information on the bottom. One fraction would have the degrees, and the other fraction will have the hours. And then solve the proportion. If you remember, cross multiply and then divide, and that will give you the unknown value. Cross multiply the two known values and then divide over the other known value, and that will give you the measure of the angle between the clock hands. 20 more seconds and then we'll do the question together. Okay, let's do the question together. So again, it's a proportion we have to set up the right way. On the bottom, it's going to be reference information. 360 is a full circle, and also one full round around the clock is 12 hours. Now we want to see the measure of angle C. Let's call that C. You can call it B, A, whatever you'd like. And then the other known value here is how many hours the clock has gone. So far, it's 2. So 2 hours. Evaluate the proportion, cross multiply, and then divide. So the measure of angle C, the unknown, equals to 360 times 2, and then divide over 12 equals to, and that will give you the angle measures 60 degrees. So that measures 60 degrees. And the answer is D. The next topic, it is in your unit, they go over how to construct angles using the protractor, using a compass, and straight edge. I'm not going to go over the details on how to do that. Those instructions are on the slide. It's just summarized for you. You can just take notes of that slide when you get the recording, write down the main broad lines of how to construct angles. And that would be that topic. The next topic I want to go over, which is going to be the last topic, I promise, it's going to be planes and solids. There is a branch in geometry we call plane geometry. So instead of dealing with points and lines, we then go a level up and deals with planes and solids. So sometimes if you think about two walls, a wall represents a plane. If two walls meet, what would be the intersection of the two walls? It's going to be a line. If you look at the first figure on the left, this is a plane, like in purple shade here, and this is a plane in blue. The intersection of two planes would be one straight line. That would be the edge of your room. So with plane geometry, we do not go into depth in that unit with plane geometry, but it's just a starting point just to use your imagination, trying to imagine two planes going through each other's, what would be the intersection? What if we have a plane and a line? What is the intersection? Think about a paper, sheet of paper, that would be the plane, and a pencil, and you put the pencil through the paper. What would be the intersection? The intersection would be the red point here. That would be the intersection, a line with a plane intersecting at a point. The one thing that needs more imagination is if you have any solid like a cone or a cylinder, for example, and you have a plane cutting through that cylinder or cone, what would be the intersection? Remember, the cone is empty from inside. It's not a solid cone, it's just a shape of a cone. So in that case, if you think about a cone and you're able to put a sheet of paper through the cone, what would be the intersection between that paper and that cone? That would be an oval. You can call it an oval. You can call it a curved line, depending on the angle where the plane intersects the cylinder or the cone. It can be a circle if it's a cylinder. If you think about which is not on the slide, but if you think about like a rectangular prism, for example, and you have a sheet of paper which represents a plane cutting through that prism, what would be the result? It can be a triangle. It can be like a trapezoid, depending again on the angle. So these type of questions, if you have any from your lesson or exam, try to use the imagination to put through the plane through that given solid, or the plane through like a line, and you will know which answer is the right answer. That is it for my math part of the webinar. We did go through lots of topics in this unit. We did look at complementary, supplementary angles. We did look at the different angle pairs forming from a transversal cutting through two parallel lines. We did have lots of practice with that. We also did do calculations with degrees, minutes, and seconds, and we did relate time with angle measure. Now, how to study for the exam? You're not expected to remember everything that you've studied for back in high school. You definitely want to read your unit. You definitely want to do the unit, do the examples within the lesson, and also do the discover more questions, or if it's called practice questions. You need to do these. The answer key for those questions are provided to self-assess yourself, to see where you are from understanding the concept, and to determine if you are ready to take the exam or no. You're able to watch that webinar again whenever you receive the recorded webinar as a resource. And also, if you want an outside resource on that topic, you can go to khanacademy.org. That is a free site that is not affiliated with Penn, but it's a great site that has lots of videos on math and other subjects. You want to go on the top left and click on subjects, and then click on geometry, and then click on geometry foundations. You will see a lot of what we spoke about in this webinar there. How do you seek help? If you are stuck on a question, you're not sure what to do, you are able to call for help from 9 to 6 Eastern Time on weekdays. We're here. You are able to schedule an appointment using that link with one of the instructors or teacher assistants. You need to come with specific questions, though, that you need to have help on. Exam questions cannot be helped on. But if you have a question on one of the practice questions, one of the topics on the lesson, will be happy to help you. If you want to text message a brief question, you're able to text message that number and text learn. Also, you are able to email your questions or chat with one of the instructors or teacher assistants from your portal. So these two will give you instructions on how to reach out for us through email or chat. For the chat feature, if you see, there is a chat feature depending on which kind of account you have. It's the same functionality, just different setup of the pages. But with the chat feature, it's available on both, or you can click on here to email your questions. Thank you everyone for attending. Thanks for your participation throughout the webinar. There is a brief survey, 3 questions only, just to give me a feedback on how I did throughout the webinar and how I can improve. So if you have the recording of the webinar you could not attend, or if you are attending today, you are able to take the survey. If you have any questions, I'll be happy to answer them before I conclude the webinar. You're able to type them in the questions box. Okay, well, if you think of any questions, then you're able to email, chat, call, or schedule an appointment. Have a good day and good luck in the exam.